In computing, ReadyBoost is a disk caching software component of Windows Vista and later Microsoft operating systems. It allows any compatible mass storage device to be used as a hard drive memory cache for the purpose of increasing random read access speed to the hard drive. Potentially compatible ReadyBoost devices include USB flash drives, flash memory, solid-state drives, and SD cards. There is a limitation of 32 GB per ReadyBoost device. Overview: using ReadyBoost-capable flash memory for caching allows Windows Vista and later to service random disk reads with better performance than without the cache. This caching applies to all disk content, not just the page file or system DLLs. Flash devices typically are slower than a mechanical hard disk for sequential I/O, so, to maximize performance, ReadyBoost includes logic that recognizes large, sequential read requests and has the hard disk service these requests. When a compatible device is plugged in, the Windows Autoplay dialog offers an additional option to use the flash drive to speed up the system. An additional ReadyBoost tab is added to the drive's properties dialog where the amount of space to be used can be configured. The minimum cache size is 250 MB. In Vista or with FAT32 formatting of the drive, the maximum is 4 GB. In Windows 7 with NTFS or exFAT formatting, the maximum cache size is 32 GB per device. Windows Vista allows only one device to be used, while Windows 7 allows multiple caches, one per device, up to a total of 256 GB. ReadyBoost compresses and encrypts, with AES-128, all data that is placed on the flash device. Microsoft has stated that a 2-to-1 compression ratio is typical, so a 4 GB cache would usually contain 8 GB of data. Requirements: for a device to be compatible and useful, it must conform to these requirements. The removable media's capacity must be at least 256 MB. Windows 7 allows up to 8 devices for a maximum of 256 GB of additional memory, with up to 32 GB on a single storage device. The device must have an access time of 1 ms or less. The device must be capable of 2.5 MB per second read speeds for 4 KB random reads spread uniformly across the entire device, and 1.75 MB per second write speeds for 512 KB random writes spread uniformly across the device. Microsoft recommends a flash memory to system RAM ratio of between 1:1 and 2.51. Other considerations: Vista's ReadyBoost supports NTFS, FAT16 and FAT32 from SP1. Windows 7 also supports the newer exFAT file system. As the ReadyBoost cache is stored as a file, the flash drive must be formatted as NTFS or exFAT to allow a cache larger than the FAT32 file size limit of 4 GB. The performance differences between these file systems is negligible on ReadyBoost. The initial release of ReadyBoost for Windows Vista supported one device. Windows 7 supports multiple flash drives for ReadyBoost, so performance improvements similar to Reader 0 can be expected. The ReadyBoost algorithm was improved in Windows 7, resulting in better performance. One experiment showed reading of flash memory up to 5 to 10 times faster than Windows Vista due to higher hit rate. Because ReadyBoost stores its cache as a file on the root directory of the drive, rather than using the flash memory without a file system, the file system must be mounted and assigned a drive letter. The ReadyBoost cache is created on the root directory of the drive. If the system drive is a solid-state drive, ReadyBoost is disabled, as reading from that drive would be at least as fast as reading from the ReadyBoost drive. ReadyBoost caches all data as it is being written to the local hard disk. The cartridge's device driver intercepts all reads and writes to local hard disk volumes, and copies any data being written into the caching file that the service created. Superfetch pre-populates frequently read data into ReadyBoost cache, so superfetch is necessary for ReadyBoost to perform well. Depending on the brand, wear and tear from read-write cycles, and size of the flash memory, the ability to format as NTFS may not be available. Enabling write caching on the flash drive by selecting Optimize for Performance and Device Manager allows formatting as NTFS. This setting will have no effect on ReadyBoost performance. ReadyBoost is not available on Windows Server 2008. According to Jim Elchin, for future releases of Windows, ReadyBoost will be able to use spare RAM on other networked Windows PCs. Performance: a system with 512 MB of RAM can see significant gains from ReadyBoost. In one test case, ReadyBoost sped up an operation from 11.7 seconds to 2 seconds. However, increasing physical memory from 512 MB to 1 GB reduced it to 0.8 seconds. System performance with ReadyBoost can be monitored by Windows Performance Monitor. As the price of RAM decreased and more RAM was installed in computers, the advantages of ReadyBoost in mitigating the performance deterioration due to insufficient memory decreased. The core idea of ReadyBoost is that a flash drive, SSD or other compatible devices have a much faster seek time than a typical magnetic hard disk, allowing it to satisfy requests faster than reading files from the hard disk. It also leverages the inherent advantage of 2 parallel sources from which to read data, whereas Windows 7 enables the use of up to 8 flash drives at once, allowing up to 9 parallel sources. USB 2.0 flash drives are slower for sequential reads and writes than modern desktop hard drives. Desktop hard drives can sustain anywhere from 2 to 10 times the transfer speed of USB 2.0 flash drives but are equal to or slower than USB 3.0 and FireWire for sequential data. USB 2.0 and faster flash drives have faster random access times, typically around 1 ms, compared to 12 ms for mainstream desktop hard drives. On laptop computers, the performance shifts more in favor of flash memory when laptop memory is more expensive than desktop memory. Many laptops also have relatively slow 4200 RPM and 5400 RPM hard drives. In versions of Vista prior to SP1, ReadyBoost failed to recognize its cache data upon resume from sleep, and restarted the caching process, making ReadyBoost ineffective on machines undergoing frequent sleep-wake cycles. This problem was fixed in Vista SP1. Limitations: since flash drives wear out after a finite number of writes, ReadyBoost will eventually wear out the drive at use, though this may take a long time, depending on various factors. According to Microsoft, the drive should be able to operate for at least 10 years. As capacities and speed rise and cost per megabyte drops, USB drives are increasingly suitable for ReadyBoost. Since some older USB flash drives which have fallen out of use for practical applications, an abundance of them can be repurposed for ReadyBoost so as to get more use until the end of the service life. See also: References. External links: Windows 7 features, ReadyBoost, Windows Vista, features explained, Windows ReadyBoost, Windows Vista help page on ReadyBoost, Windows Vista, features explained, performance features, Channel 9 interview with Michael Fortin on ReadyBoost and other performance technologies in Windows Vista, section Storage 009 and Windows Logo Program Requirement Suite, version 3.09, understand ReadyBoost and whether it will speed up your system, Microsoft software patent on ReadyBoost, AnandTech, Windows Vista Performance Guide, ReadyBoost, ReadyBoost Performance Analysis, and Hard Drive Performance and ReadyBoost, how to use and configure ReadyBoost, in-depth Tom's Hardware article with analyses of ReadyBoost. And Superfetch.